Jain everyone. I am Shruti Jain, Assistant Professor from MCA Department, College Ajay Kumar Garg Engineering College, Ghaziabad. Today we are going to discuss about the topic of software maintenance. This topic is covered in software engineering subject. Subject code is KCA 302 and it is for the students of MCA 3rd SEM 2nd year. So coming to software maintenance. Maintenance is basically a phase of software development wherein once a software is already developed and given to the user, the customer, then after a certain period of time, the maintenance of the software is required. Now this maintenance could be because of the change in the technology or change in the user's demand, or some of the features of the software need to be omitted or need to be removed from the software because they are no longer in use, or it may be a possibility that new features in the software needs to be installed. So all these things lead to the maintenance of the software. So maintenance of the software or the software maintenance. Now first let's understand what software maintenance if we are talking about it as an evolutionary entity. So software maintenance includes error correction, enhancement of capabilities, deletion of obsolete capabilities and optimization. The way that is what we have discussed just now, that maintenance is required because some of the features become already obsolete, they need to be removed, or some of the features need to be added, maybe because the user is in need of those, or some errors have been encountered while the user was using the software. All these things lead to the software maintenance. As changes cannot be avoided, we should develop a mechanism for evaluating, controlling and making the modifications in the software. Because with the advent of technology, with the change in the technology after a certain period of, hence any work done to change the software after its operation is considered to be the maintenance work. The term evolution has been used with reference to software since 1960s to signify that the software keeps on changing after a certain period of. So software maintenance, as we have just discussed, that it includes the error correction, enhancement of capabilities, deletion of obsolete capabilities and optimization. It is needed to correct the errors that the user has just encountered or the user has encountered while he was using the software. Enhance the features if you want to make any of the changes in the software, or maybe you want to add new functionalities into the software. For that we need to do the maintenance. Then port the software to new platform. Maybe they need to change the platform, or they want to run it on different platforms. So for that the software maintenance is required. So 70% of the cost of the software is devoted to maintenance, maybe because once the software is developed, that is one such phase, but the maintenance of the software keeps on till the life of the software. So that is a longer phase as compared to rest of the phases of the software development model. Now the software development model constitute the phases of the first one, requirement analysis, then designing, then the implementation, then the testing phase. Once the testing is done, it is deployed at the user's end, and once it is deployed at the user's end, later the software maintenance phase comes. Now, why do we need to have the maintenance in the software? Because the demand of the user community to see the existing software products run on a newer platform. The platform that he was already using, maybe because maybe it has become obsolete, or there is a need to change the platform on which it is running. That is maybe because maybe earlier the user was using the Windows, now he wants to port the same software onto the Linux. So demand of the newer platform, newer environment, or with the enhanced features. So when the hardware platform is changed and the software product performs some low level functions, again the maintenance is necessary. Because it is not necessary as soon as you change the platform, the software will run the way it was running earlier onto the earlier platform. There might be certain changes that might be needed into the software. So for that, the maintenance of the software is needed. software maintenance is becoming an important activity of the large number of software organizations, because once the software is developed, the maintenance goes on for a longer period of time. Now, why do we need the maintenance? The first one is the correction of errors. The correction of errors means the software is already developed. Now, the user encounters some of the errors, or the software is not giving the output which was required with that certain input. So, correction in the errors, change in the user requirements with the time. Earlier, the user would be requiring some things, but with the change in time, there might be a necessity of some more requirements to be added. So, those changes lead to the maintenance in the software. Changing the hardware or the software environment, maybe because the user wanted to change the platform on which he is running, or some other hardware things need to be changed. To improve the system efficiency, to optimize the code to run faster, to modify the components. The components means some of the modules or some of the changes made into the program or the software. To eliminate any unwanted side effects. So all these are the reasons why the software maintenance is needed. Thus, maintenance is needed to ensure that the system continues to satisfy the user requirement, because the ultimate aim of the user is to, the developer is to satisfy the user. So whatever software the company is developing, that is developed in order to make the user satisfied. So whatever the requirements of the user are, those requirements need to be satisfied by the developer. Now we have different categories of maintenance. The first category of maintenance is corrective maintenance. Corrective maintenance is to rectify the bugs that have been encountered while the system was in use. So whenever we are making the corrections into the software to remove the bugs or to remove the errors, the next type of maintenance that we have is adaptive maintenance. This is required when the customer need the product to run on the new platform, on a new operating system, or when they need the product to interfere with the new hardware or software. So here they want their already existing software to adapt to new changes in the sense of the new environment, the new platform, the new operating system and all. Then comes the perfective maintenance. This maintenance is required to support the new features that the software that the user wants to support, to change different functionalities of the system according to customer's demand, or to enhance the performance of the system. So all these come in the perfective software, where new features need to be installed or new features need to be added into the software. Preventive. There are long-term effects of corrective, adaptive and perfective changes. This lead to an increase in the complexity of the software. So to prevent any deterioration into the software, we need to have the preventive maintenance. So all the above maintenances that we were doing, the correct, so that might increase the complexity of the already existing software. So to avoid that complexity or to maintain that complexity, we have the preventive maintenance. So if we look into the distribution of the maintenance, the preventive maintenance has the very less share, wherein whatever changes we are making in the software, those are taken care of. The most area is covered by the perfective maintenance. Now, perfective maintenance, as we have seen, that it is to support the new features that the user want. So, the new features, mostly the user need to have more features into the software. So, the most of the area is covered by the perfective. The almost equal share is taken up by the adaptive, where the new platform, new hardware of the software platform is required. And the other one is a corrective, wherein the bugs are being checked or removed. Now, there are certain problems that occur while the maintenance phase is going on or the maintenance of the software is done. The first thing is, often the program is written by another person or the group of person, because by the time the project enters into the maintenance phase, it may be a possibility that the team who developed the software or the team who was involved while the software was in the initial phases, that has changed. This leads to a change in the mindset of the people, and thus leads that might be a problem while the software is in the maintenance phase. Often the program is changed by a person who did not understand it clearly. While there was a change required in the software, the changes were made by a person who was not very much thorough with the concept, or who was not very much clear what the program is basically doing. Those were incomplete, or those were not up to the mark, due to which the person who is now maintaining the software, it is difficult for him. High staff turnover, change in the staff personnel. Information gap, the passage of information from one personnel to another, there is a gap in it. Systems are not designed for change. The system is being developed in such a way that making a change in it is very difficult. The complexity of the software is very high. So those were the problems that we discussed. Now, what could be the possible solutions if those kind of problems come? The first one is budget and effort reallocation. So the budget that has been decided earlier when the software was into different phases, those budgets and the resources needs to be reallocated. Even the people who are involved in the maintenance phase, they also need to be reallocated, so that the software can move into the maintenance phase very smoothly. Complete replacement of the system, though it is not recommended that they should be there, but if, as we have seen the last one, that the systems are not designed for change, and if the user requirement is a change or the enhancement of the feature or addition of new feature, then at the least that can be done is the complete replacement of the system. The software needs to be developed again, considering the user's requirement. Then the maintenance of the existing system. The existing system that we have, we need to make a change in it, so that the customer is satisfied, and everything that the customer wants is included into the maintained software. So now this is a maintenance process. The first thing is to determine the maintenance objective. Why are we maintaining the software? Those objectives need to be very clear. Now, those objectives could be correction of the program or the errors, enhancement of features, deletion of obsolete features, or optimization, or maybe adaptability. So, we need to identify what is the maintenance objective. The objectives could be to correct the program errors, to add new capabilities or to add new features, delete obsolete features which are no longer in use, and the optimization. Then the first phase, program understanding. Program understanding is, now we have identified the objective. Now we'll try to understand what exactly the software is, because the software is already developed. So to understand the program, we'll understand the complexity, its documentation, and its self-descriptiveness. Self-descriptiveness is basically the comments that are being added into the program for easy understanding or readability of the program. So once it is done, a maintenance proposal is being generated, which talks about the extensibility, the extensions that we are adding into the software. Account for ripple effect. What effect will it make into the already existing software? That checks the stability of the software. Then once everything is being done, it is again tested whether it is giving the optimal result or not. So that encounters the testability. If it passes the test, then the software is released. If it doesn't pass, then the cycle is again started from the maintenance phase. Now we have different maintenance models. The first one is quick fix model. The quick fix model is nothing but, as soon as the problem is encountered, we try to fix it, and then the cycle moves on. It is like, you found a problem, you fix the problem and release the software. Again, a problem is encountered, you fix that problem and release the software. So it is a simple one, but it is very rarely used, because every time encountering a problem and fixing it is not feasible. The next one that we have is iterative enhancement model, which has the 3 phases. The first one is analyzing the existing system. We analyze how the already existing software is working. Then characterization of the proposed modification. Then we characterize them, or maybe on the basis of the priority, we try to identify at what all places we need to make the modifications. We redesign the software and do the implementation, and later on, after testing the software, we provide it to the user. So this changes the current version of the software. So we redesign the current version, maybe we provide another version of the software to the user after the changes are being made into the software. The next one that we have is Boehm's model. Boehm proposed a model for the maintenance process based upon the economic models and principles. So here, the first one is the management decision. The management decides where all the changes need to be made. Once the changes are approved, those changes are implemented. That results into a new version of the software. Then it is evaluated in the sense that it is being tested whether it is giving the expected result or not. So that those proposed changes are being evaluated, and if the software is running up to the mark, if the software is moving as per the user's requirement, then the software is released with a new version. Now, the next topic that we have is software reverse engineering. Now, software reverse engineering is a process of recovering the product's design and requirement specification from analysis of its code. That means we analyze the code slowly and steadily, and we move into the first phase of the software development. So the purpose of reverse engineering is to facilitate the maintenance work by improving the system's understandability and producing the necessary documents for legacy system. It is a process followed to find out the difficult, unknown, and the hidden information about the software system. Now, reverse engineering is basically, if we look into the figure over here, we have the code of the software. We try to identify the different modules that are available. Once the modules are being identified, we move into the design phase, and then we move into the requirement phase. That means when the software is being developed, it is moving into first to the last phase over here. But in the reverse engineering, because we already have the code of the system, so we move into the opposite phase from the last till the first. Now coming back to the reverse engineering, it may be a part of re-engineering process, but may also be used to re-specify a system for re-implementation. If we want to make a new changes or re-implement some of the parts of the software, for that we can move into the reverse engineering phase. The main purpose of reverse engineering is to recover the information from the existing code or any other intermediate document that already exists into the software. Any activity that requires a program understanding at any level that falls within the scope of the reverse engineering. So scope and task, the first one is redocumentation or the documentation generation. We already have the documentation, so we move into the redocumentation phase. We want to have more detailed documentation. Recovery of the design approach and the design details at any level of abstraction. We want to we already have some designs. Now we want to recover those designs or the details at any level of abstraction, at any level of the software that is being developed, to identify the reusable components so that they can be used maybe into another software of the similar type. Identifying the components that need restructuring, maybe that is in user's demand, that needs to be restructured, or that is becoming obsolete, so need a maintenance into it. Recovering business rules, understanding high-level system description. So as we have already seen the process, the actual when the software is being developed, we move from requirement phase to the design phase and the module specification. and the coding phase. But once we are into the reverse engineering phase, we already have the code with us, so we move into the opposite direction where the code is given, the modules are being specified, the design of the software is being checked, and we move to the requirement phase from coding phase into the reverse engineering. So if we look into the reverse engineering process again, we have the original program, the program that the user is using. That program is translated into the source code. That source code moves into two parts, either into the reverse engineering or the program structure improvement. We want to improve the program. Now, when it moves into the reverse engineering, the program documentation is being checked, and for structure improvement, the structured program is being seen. These both of them lead to the program modularization. We convert the program into different modules. So the outcome of this program modularization is we get a modularized program. We already have the original data. So while we are moving from original program to the modularized program using the reverse engineering phase, we get into the data re-engineering. Everything is re-engineered. Now, improvement, we want to make a change we want to improve the structure of the program. We move from here to the structured program. This again comes into the modularized program. We already have the original data, that again leads to the data re-engineering. So this re-engineering data leads to the re-engineered data or the re-engineered program that again is given to the user. So now let's understand what software re-engineering is. So software re-engineering is concerned with taking existing legacy systems and re-implementing them to make them more maintainable. We are trying to make them more maintainable. We try to re-implement them so that it is more optimized. Reorganizing and modifying existing software systems to make them more maintainable. Restructuring or rewriting part or all of the system without changing its functionality. It may be a possibility with the advent of new technologies. It could be a possibility that the already existing software is working fine, but it could be optimized. It could be speeded up with the new technologies. So we need to restructure or rewrite a part or all of the system without change, but the functionality doesn't change for the customer. Applicable when some subsystems of a larger system require frequent maintenance. Frequent maintenance could be the errors are coming or maybe the speed issue is there. So all those things need a frequent maintenance. Re-engineering involves putting in effort to make it easier to maintain. The critical distinction between re-engineering and new software development is the starting point for the development as shown in this figure. So if we look into the new system, we start from system specification. System specification means we try to identify the requirements of the user and slowly we design and implement the software, and at the end we get a new system developed by the developers. So here we started from the scratch, we gathered the requirements from the user, try to identify what are the specifications. Then on the basis of that, we designed and we did the coding, and at the end we got the new system that is being provided to the user as per the user's expectation. So this is forward engineering, wherein the software development started from the scratch and a new software is being delivered to the user. Now when we are into the re-engineering phase, we already have a software. So we have the existing software system. We are making a changes in it. We try to understand that system and we try to transform it into a new system that is more maintainable, that is more optimized and is for the use of the user. So here we have the existing software system. We already have a system. Here the new system was developed. Now when we are moving into the re-engineering phase, we already have a software system that is provided to us, to the developers, for understanding and making the transformations. Once that understanding and transformation is being done, it moves into the re-engineered system. So they get a system, but that is a re-engineered one. The already existing system moves into the understanding and transformation phase, and at the end we are provided with a re-engineered system that is more maintainable. So the re-engineering process, here we have the system to be re-engineered, the process that needs to be re-engineered, that moves into either the automated analysis or manual annotations, depending upon how the changes are to be made. That moves into the store, the database where the system information is being stored. That leads to the documentation generation. This documentation generation is in the form of program structure diagrams, data structure diagrams, or traceability matrices. So the advantages of re-engineering are reduced risk, because we know that there is a high risk in the new software development. So re-engineering reduces that risk. There may be development problems, staffing problems, and specification problems when a new software development is being done. But when we already have the software with us, we need to re-engineer it. So the risk is being reduced. The next one is reduced cost. The cost of re-engineering is often significantly less than the cost of developing a new software, because when we are developing a new software, it has to move into different phases, starting from gathering the requirements from the user till the coding and implementation and then testing. But when we are into the re-engineering phase, we already have the existing software. We only need to modify it and understand what the software is. So here the cost is comparatively very less as compared to a new software development. Thank you.